Imagine a world without rivers or lakes. Where would we get the water we need to drink, to grow our food, to sustain life itself? The answer lies beneath our feet, in vast underground reservoirs known as aquifers. These hidden treasures are the key to our survival, providing a lifeline of fresh water that sustains both ecosystems and humanity. Aquifers are not just geological formations. They are dynamic systems that play a crucial role in the global water cycle, collecting and storing rainwater that seeps through the ground. Understanding the importance of aquifers is not just a scientific endeavor. It is a matter of safeguarding our collective future. Aquifers are a gift from nature, a testament to the Earth's remarkable capacity to store and distribute water. They are found on all continents, silently supporting life in the most arid and unexpected places. From the vast Ogallala Aquifer that sustains the heart of the United States to the vast Nubian Sandstone Aquifer System beneath the Sahara Desert. These underground reservoirs provide a vital buffer against drought and water shortages. Its importance cannot be overstated, since they hold the promise of a future with water security, but only if we act now to protect them. Imagine the rain falling on the earth, filtering through layers of soil and rock. This is the beginning of an aquifer's journey, a slow and steady process of replenishment. As rainwater percolates downward, it encounters layers of porous and permeable rock, such as sandstone or fractured granite, where it can accumulate over time, forming vast underground deposits. These reservoirs, known as aquifers, are not underground lakes, but rather areas of saturated rock and sediment where water is stored within the small spaces between grains or fractures. There are two main types of aquifers, free and confined. Unconfined aquifers, also known as unconfined aquifers, are connected directly to the ground surface. The upper limit of an unconfined aquifer, where the water table fluctuates with rainfall and use, is called the water table. Imagine digging a well. They would have to reach the water table to access water stored in a free aquifer. Confined aquifers, on the other hand, are sandwiched between layers of impermeable rock, such as clay or shale, that act as confining layers. These layers restrict the movement of water both into and out of the aquifer. Confined aquifers are often found at greater depths than unconfined aquifers and may be under pressure, leading to the formation of artesian wells, where water flows to the surface naturally without the need for pumping. Understanding the different types of aquifers and how they work is crucial to managing our groundwater resources effectively. Our groundwater resources, the lifeblood of many communities and ecosystems, are facing an unprecedented crisis. Overexploitation, climate change, and pollution are conspiring to deplete and degrade our aquifers, endangering the delicate balance of these vital resources. The consequences of inaction are dire, threatening not only our water security but also the health of our planet. Overexploitation, the extraction of groundwater at rates that exceed natural recharge, is one of the most urgent threats to the sustainability of aquifers. Driven by growing demand for irrigation, industrial use, and a growing population, overexploitation has led to declining water tables, land subsidence, and even saltwater intrusion into coastal aquifers. The consequences are particularly serious in arid and semi-arid regions, where groundwater is often the main source of fresh water. Climate change is exacerbating the problem by altering precipitation patterns, leading to more frequent and severe droughts in some regions. As temperatures rise, evaporation rates do too, further depleting surface water sources and reducing the amount of water available to recharge aquifers. This double whammy of reduced recharge and increased demand is putting immense pressure on already stressed groundwater systems. Pollution from various sources, including agricultural discharges, industrial waste and sewage disposal, is another major threat to aquifer quality. Contaminants can infiltrate aquifers through the soil, contaminating groundwater and making it unsafe for human consumption. Once an aquifer is contaminated, it can be extremely difficult and expensive to remediate, endangering the health of communities that rely on groundwater for their water supply. The crisis of aquifer depletion is not limited to a certain region. It is a global phenomenon with alarming implications for water security and human well-being. From America's breadbasket to the arid plains of India, aquifers are being overexploited at unsustainable rates, threatening the livelihoods of millions of people and the health of our planet. The Ogallala Aquifer, a vast underground reservoir that extends beneath 8 states in the American Midwest, is a perfect example of the challenges facing aquifers around the world. Known as America's breadbasket, the Ogallala has been instrumental in transforming the region into an agricultural powerhouse, but its overexploitation is jeopardizing its long-term viability. Water levels in the aquifer have been declining steadily for decades, and in some areas, the aquifer is being depleted at a rate 50 times faster than it is recharged. In India, where the highest rates of groundwater extraction in the world are found, the situation is equally dire. The overexploitation of aquifers has caused widespread water shortages, especially in the country's agricultural heartland. The depletion of groundwater resources is threatening food security, worsening rural poverty and fueling water conflicts. The Ganges Basin, home to a population larger than that of the European Union, is facing a particularly severe water crisis, with groundwater levels plummeting due to overexploitation for irrigation and domestic use. The consequences of aquifer depletion are being felt around the world, from the drying up of lakes and rivers to the sinking of cities. Central Asia's Aral Sea, once the world's 4th largest lake, has shrunk to a fraction of its original size due to water diversions for irrigation, a stark reminder of the ecological and human cost of unsustainable water management practices. The future of our water security depends on our ability to manage aquifers sustainably, ensuring these vital resources are available for generations to come. It is a collective responsibility that requires a paradigm shift in the way water is valued, governed and used, that recognizes the interconnection of surface and groundwater systems and the need for integrated water resources management. Reducing our dependence on groundwater is paramount. This requires a fundamental change towards more efficient irrigation practices, like drip irrigation and precision agriculture, that supply water directly to the roots of plants, minimizing evaporation and runoff. Invest in drought-resistant crops, and promoting crop diversification can also help reduce agricultural water demand. Recharging our aquifers is equally crucial. This can be achieved through various methods, such as rainwater harvesting, artificial recharge of aquifers, and managed aquifer recharge. Rainwater harvesting involves collecting and storing rainwater for later use, reducing runoff and recharging aquifers. Artificial recharge of aquifers consists of injecting treated wastewater or stormwater into aquifers through wells or infiltration basins, while managed aquifer recharge consists of improving natural recharge processes through the restoration of wetlands, reforestation of watersheds, and the implementation of permeable pavements in urban areas. Protecting our aquifers from contamination is essential. This requires minimizing the use of pesticides and fertilizers in agriculture, treat industrial wastewater before discharge, and ensure the safe disposal of wastewater. It is essential to promulgate and enforce strict regulations on groundwater pollution, as well as raising public awareness about the importance of protecting our groundwater resources. The time of complacency is over. The future of our water security, our food systems, and our planet is at stake. We must act now, with urgency and determination, to protect and restore our aquifers, these hidden treasures that sustain life on Earth. Each individual has a role to play in this collective effort. By reducing our water consumption at home, support companies that prioritize water sustainability, and advocate for responsible water policies, we can make a difference. We must become guardians of our water resources, recognizing that every drop saved, every drop conserved. It is a victory for our planet and future generations. The challenge before us is great, but so is our capacity for innovation, collaboration, and collective action. Let's rise to the occasion, embracing the principles of responsible water management and working together to ensure a water-secure future for all. The fate of our aquifers, and in fact our planet, depends on it.